All right, everyone, welcome back to the Math Mindset, and today we'll be continuing with the last installment of our ACE SAT Geometry series. And this is our part 3, our last part of this series. So please do follow along and pause and try these problems yourself. And we'll get started right away. Okay, so question number 33 says, in rectangle PQRS, arcs QT and RT, okay, so these arcs, so that arc and that arc, QT and RT, are quarter circles with centers at P and S respectively, okay? If the radius of each quarter circle is 1, what is the area of the shaded region? Okay, so the radius of each quarter circle is 1. So I'm going to mark all the radii. So that's 1, that's 1, that's 1, and that's 1. So this is a 2 by 1 rectangle, right? And we want to find this, the area of the shaded region. This is what we want to find. Well, we can do that by subtracting off the area we don't want, this area. So our answer will just be 2 minus whatever the red area is. So let's try and find the red area. Now, like the problem said, the red area is just 2 quarter circles with radius of length 1. Now, if you put 2 quarter circles together, they make a semicircle. So the 2 quarter circle, so the total red area is just 2 quarter circles together. That's just the semicircle with radius 1. Now we know a circle with radius 1 has area pi r squared, or pi. And the area of a semicircle with radius 1 is just pi over 2. So our final answer is just 2 minus pi over 2. And that's choice B. Right? Let's move on. Number 34 over here. The cube shown above has edges of length 2, and A and B are midpoints. Okay, of the two edges, what's the length of AB not shown? So we're going inside this rectangular prism, and we want to find the length of AB. Okay? So how can we do that? Well, we're going to need some right triangles. Right? We know that the side lengths of the cube are all of length 2. Right? And A and B are the midpoints of these sides. So this is 1, and then this is 1, and this is 1. Right? And we want to find the side length AB. So if we draw a net of this cube, so if we unfold this cube basically, what it'll look is something like this. So this is our center face. Actually, let me do this one and this face in red. So this face right here will be our bottom face. Right? So that's our bottom face. So A will be right here. A will be right there. And when we unfold this cube, this green face right here will be to the right of the bottom face when unfolded. So we'll have this green face right here. Actually, let me move this. So let me get this. Let me move it over here. Okay. So this green face right here will be right next to the bottom face in red when unfolded to the right. And B will be right here. Let me see. This is B. Right. And then we have the other faces. The other 4. So we have this face, right? We have this face, And we have this face, and then we have the other face, right? Like that. So that's like the net of a cube. But here we want to find AB. It's just this line segment right here. And here we can, this is actually a right triangle. This right triangle. We know B is the midpoint of a side, so it has length 1. The square has length 2, and then we have this half segment right here. So in reality, AB squared is just 3 squared plus 1 squared. So AB squared is just 10. And AB is equivalent to the square root of 10. That's choice E. And we're done. So in these like three-dimensional problems, it's usually helpful to unfold whatever 3D figure you have, draw it down and visualize it in a 2D form, like as a net, like I did with this cube, and then use that to solve the problem, because it's much easier to work with 2D figures rather than 3D figures. But anyways, enough said, let's move to number 35. In the figure above, what is the value of C in terms of A and B? Okay, so we just have to angle chase here. And for the moment, we will focus on these three triangles that I've circled here. I'm just going to write all of them in terms of A and B. Okay. So let's fill in the missing angles. So first, I'm going to fill in this angle right here. This angle is just 180 minus A minus B, right? Again, the same thing. Here, it's just 180. Actually, let me draw an arrow out. This angle, this is 180 minus A minus B. And this angle is just 180 minus B minus C. Right? These three angles. But if you notice, these three angles sum to 180 because they're all on a straight line. So what we can do is we can add these three expressions together and let them equal 180. And we can just see what happens. And we can solve for C like that too. So let's do that actually. Okay. So we have 180 times 3, so it's 540. 540 minus, how many A's do we have? We have minus 2A, and then minus 3B, right? Minus 2A minus 3B minus C is equal to 180. Right, we can subtract 180 from both sides. Right, this side becomes 0. We can change the 540 to a 360. Right, so this is a 360 now. And we can just solve for C by adding C to both sides. So we'll get C is equal to 360 minus 2A minus 3B. And that's answer choice E right here. Right here. Let's see. It's answer choice E. And we're done with this question. Alright, number 36. Okay. Let's see. In right triangle, ABC above, EF is parallel to AC. So I'm going to mark that down real quick. Where is EF? So, okay, so this side of the rectangle is parallel to AC. Alright? And F is the midpoint of BC. So F is the midpoint. So what we know, if F is the midpoint, is that this region right here, let me just draw it better, hold on. Let me actually do it in red. This region is 5 root 2. And then this region is, again, 5 root 2. Right? And because EF is parallel to AC. That means E is also a midpoint, right? So this will also be 5 root 2, and this will also be 5 root 2, right? And then we want the area of the shaded rectangular region right here. Okay. All right. First of all, what we want basically is EF times, I'm going to mark this point, I'm going to call it X. We want EF times FX, right? Right, this is the value that we want. Right, so first let's go about finding EF. Right? Now, by triple angle similarity, right, we know these lines are parallel, this entire thing. So this angle will be equal to this angle, that angle will be equal to that angle. We know they're similar. So we know, what we know is, let me write this in black, triangle EBF is similar to triangle ABC. Yeah, that's clear. And the similarity ratio between these two is 1 to 2. Right? Which means, let's see. Which means EF, which is what we want to find, over AC is equal to 1 over 2. Correct? But we know what AC is. AC, by the Pythagorean theorem, is the square root of 10 root 2 squared plus 10 root 2 squared. So it's the square root of 200 plus 200, which is 400, which square root of which is 20. So here we know, okay, EF is 10. Right, we know what EF is. So now we can change what we're looking for to 10 times FX. Correct? We want to find FX now. We want to find this length. And again, we can use similar triangles. Right? Both triangle ABC and triangle FXC share a right angle, and this angle in green I'm drawing right now. Right? So by similar triangle ratios, we can say the triangle, let me actually erase this work for the previous similar triangles and write it down. So triangle, right, CXF is similar to triangle CB, not O, but CBA. Yeah. So we know FX over AB will be equal to CF over AC. Now CF, we know, is 5 root 2. AC, we know, is 20. So we can simplify this. We know the ratio is now root 2 over 4. Right, FX over AB. Now what is AB? AB is just 10 root 2. That's it. Right? So we can cross multiply here. We get 4FX is equal to, let's see, it's equal to 20, so FX is equal to 5. So we know what our area is. It's just 10 times 5. That's just 50. And we're done. Admittedly, you could have done this a lot faster if you knew your similar triangle rules. Not similar triangle rules. Special triangle rules for 45, 45, 90-degree triangles. But I'm just trying to show you how you would approach this problem if you had forgotten what those ratios were or had no clue what they were. But you should memorize them because they will come in handy in problems like number 36. Well, okay. Number 37 here. Naomi makes silver jewelry. For one style of earrings, she cuts wedges from a silver disc, as shown in the figure above. Okay. Each wedge makes a 40-degree angle at the center of the disc. If the weight of each uncut disc is a uniformly distributed 25 grams, how many grams does each wedge weigh? Okay, let's see. So the weight is uniformly distributed. So whatever portion we take, we can always relate it to the ratio of the angle the wedge makes with the center, in this case 40 degrees, with the amount of degrees in a circle, which is 360. Right, so that's our circle. It's our disc. Right? And they're saying the weight, I'm going to call the weight of the wedge W. The weight of the wedge W and compared to the weight of an uncut disc, 2.5 grams, or rather, the proportion of the weight of the wedge W to the weight of an uncut disc, 2.5, is equivalent to 40 degrees over 360 degrees. And the only reason I can make this proportion is because we know that the weight is uniformly distributed. Right, so we can just solve this proportion. W over 2.5 is equal to 1 over 9. Right, 9W is equal to 2.5. Right, and then we have, let's see, W is equal to 2.5 over 9, which is 5 over 18. So in grams, each wedge weighs 5/18 of a gram. Okay, number 38. Let's see. The flag above is made by overlapping equilateral triangles ADF and BCE, okay? Because ribbon is to be sewn around the entire outer edge, it is necessary to know the perimeter of the flag. If CD, DE, and EF each have length 10 inches, what is the length in inches of the perimeter shown in bold? Okay. So what they're saying is, this is 10, this is 10, and this is 10. Right? CD, DE, and EF are each 10. So we just want to find the length of the perimeter, or the perimeter of the flag. So we want to find the length of the original equilateral triangles for us to do that. Now CF is 30. Right, the entire thing. This entire segment, I should do this in a different color. This entire segment is 30. And it encompasses two side lengths of an equilateral triangle. Right? So I can say it's equal to 2x. Right? But each of these lengths counts DE once, right? But we're counting DE twice. So what we can say is we need to remove one instance of this 10. So we get 2x equals 40, x equals 20. Right, so we know the side length of an equilateral triangle is 20. Right, so we can just say, alright, we can start labeling sides. Right? Oops, let's see. This is 20. This is 20. We know CF is 30. But we need to know what these two side lengths are. Right? But it's pretty easy to see that this is an equilateral triangle as well. So we know this is 10, and that's going to be 10 as well. So we can just add everything up. We can do 20 plus 10 plus 10, that's 40. So this is 60, right? 60 plus 30 is going to be 90. And that's the perimeter of this flag. So 90 inches. And we're done, right? It says 30, 50, 60, 70, 90. Yeah, okay. In the figure above, EBCD is a square and AE is 8. Okay, what is the area of EBCD? Alright, we know this angle is 60, so this angle is 30. Right? We want to find the area of EBCD, and we know it's a square. So if you just find what EB is, we'll be done, because we can just square that and find the area. Now, this is where it's very helpful to know your special triangle rules. Right? We know in a 30, 60, 90 triangle that the side opposite the 60-degree angle is root 3 times the side opposite the 30-degree angle. So here EB is just 8 root 3. And the area of EBCD is just 8 root 3 squared, which is 192. And that's our answer. Okay, number 40. Ooh. In the figure above, PQST is a rectangle. Okay. And URST is a square. PU is equal to 5. Okay, I'm going to write that down. And UT is a positive integer. If the area of PQST must be more than 10, but less than 30, what is one possible value of UT? Okay, so I'm just going to call UTX, right? Since we're trying to find the possible values of UT, I'm going to give it a variable. All right, so if UT is X, ST is also X. And we know that the area of the rectangle, which is 5 plus X times X, has to be between 10 and 30. Right? And we know UT is a positive integer. So let's see what values work. If we plug in 1 in, this thing is 6. So it clearly won't work. So if X is 1, we get 6. It's not working. If X is 2, we get a 5 plus 2 times 2. That is, what? 14. That works. If you get X is 3, or we get 24 out as a result. But if we plug in X is 4, then we start getting too big. Then it's above 30, so no. And anything higher won't work. So X equals 2 and 3 are the only values that work. And if we want one possible value of UT, I'm just going to pick 3 and submit that. But you can pick 2 as well. Doesn't matter. We just want one possible value of UT. And we're done. Number 41. In the figure above, what is the area of the shaded square? Okay. So we have a square with side length 3, right? And what it looks like is we have these rectangles, right? We have this triangle here, and it looks like we're just rotating it over and over again, right? So what this looks like, oops, what this looks like is this is a 2 by 1 triangle, right triangle, just rotated over and over again, right? So this will be 2, this will be 1, this will be 2, this will be 1, this will be 2, this will be 1. Right? It looks like it's just rotated over again. Each of these triangles has area 1. And this is a square with side length 3. So the area of the shaded square is just 3 squared minus 4 times 1. That's just 5. And it looks like that's the answer. Okay, 42. 5 points A, B, C, D, E lie on a line, not necessarily in that order. Let me draw a better line than that. Okay, AB has a length of 24. Point C is the midpoint of AB, and point D is the midpoint of AC. Okay, so I'm just going to say A and B are like right here. And it has length 24, obviously. Point C is the midpoint of AB. Alright, so then this is 12 and that's 12. And then point D is the midpoint of AC. So we have this right here. So this is 6, this is 6, and then that's 6. And if the distance between D and E is 5, what is one possible distance between A and E? Okay, so I'm just going to say E is here, right? The distance between D and E is 5. So this is 1, right? Here, in this case, the distance between A and E is just 6 plus 5. That's 11. But if E was on the other side of D, so if E was right here, right, then the distance between A and E would only be 1. So the answer is either 11 or 1, depending on where you put E. Yeah, and that's question 42. Let's move on. Let's see. Okay, we only got 3 questions left. So, we'll be able to do this. Okay. In triangle PQR, all right, above, QS over QV is 1 over 3, and PT over PR is 3 over 4. What's the value of the fraction area of PST over area of PQR? Okay. So I'm going to assign variables. So if QS is X, QV is 3X, right? QV is 3X, that means this segment is 2X, right? Okay. And PT over PR is 3 over 4. So if this is 3X, then TR, or rather, I'm going to give a new variable for it. If PT is 3Y, then TR is just Y. It's like that, right? And we want the value of the fraction area of PST over area of PQR. Now the area of PST in terms of X and Y is just 2X times 3Y by 2. That's 3XY. The area of PQR is 3X times 4Y by 2, which is 6XY. Now the ratio they're asking for is just 3XY over 6XY is just 1 over 2. And that's our answer. Number 44. Tamika cut a circular pizza into wedge-shaped pieces. The tip of each piece is at the center of the pizza, okay, but the angle at the tip is always greater than 20 but less than 30. What is one possible value for the number of pieces into which the pizza is cut? Right? So we know that the angle of this wedge, so this angle, I'm going to call it x, is between 20 and 30. Right? And this angle x, well, it doesn't have to evenly divide 360 because that's not specified in the problem. But we could finish this a lot quicker if it did. So let's just say 300x divides 360. So let's just say 360 is divisible by x. So if I can, let me write out the prime factorization for 360 and see if we can find a factor x between 20 and 30. So this is 2, this is 180, 290, 245, 3 squared, and then 5. So the prime factorization is 2 cubed times 3 squared times 5. Right? And it looks like there is a factor we can assign for x. We can make it 2 cubed times 3. This is 24. Right? This is a factor of 360, but is between 20 and 30. Now we just have to figure out how many wedges we can cut. So this is just 360, which is 2 cubed times 3 squared times 5. Divided by 24, which is 2 cubed times 3. 2 cubes cancel. We get rid of a 3. This is just 3 times 5. This is 15. And that's one possible value. Alright, number 45. In the figure above, M is parallel to N, and L bisects angle ABC. If y is between 45 and 55, what is one possible value for x? Well, okay. If this is angle y, then so is this by the corresponding angles theorem for parallel lines. And if line L bisects ABC, this angle is y by 2, and this angle is y by 2. So that means this angle is y by 2, and this angle is y by 2. Now, we want to represent x as something in y. So let's angle chase and see where we get. Right? So immediately I know, okay, angle x is congruent to this angle right here. And this angle, that's just 180 minus y. Let me actually, I'm going to redraw this triangle to make my point clearer. This triangle. It's obtuse, hold on. Right? So like I said, this angle right here, which I found, is y by 2. We are concerned with this angle. This angle is our x. Right? And we know already that this angle is 180 minus y. Right? And we know this angle is equivalent to x by the vertical angles theorem. So we can just write an equation here. We can say 180 minus y plus y by 2 plus x is equal to 180, the sum of the angles in a triangle. Now the 180s cancel, so we just get x minus y by 2 is just 0. So we get x is equal to y by 2. So if we pick an even angle for y, we can get a whole number for x, and we like whole numbers. So I'm just going to pick the first even number for y, 46. Let's just say y is 46. So then x can be 46 divided by 2, which is 23. And we're done. But anyway, guys, this concludes our geometry series for SAT geometry. I hope you enjoyed, and I'll see you very, very soon. Thank you for watching, and please subscribe. Thank you.